I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are discussing rational functions, and in this video, we will see what are oblique asymptotes, how do we find them, and what is the end behavior of the function. This should give you good understanding of graphs of rational functions. Join my classes by sending the email on the address given. Let us enjoy the lesson with Aryan. Hi Aryan, how are you doing?
Hi, sir. I'm doing good. How are you doing?
Very good, very good. So, today, what do you want to do?
Yeah, I'd like to continue rational functions.
Correct. So, let me share with you what you had shared, correct?
Yeah,
Uh,
as well. And like,
Oblique asymptotes.
yeah,
Okay.
yeah.
We cannot discuss oblique asymptotes.
Yeah.
So, you are actually doing rational functions, right?
Yeah, yeah.
So, when do you get oblique asymptotes? Tell me.
Yeah, basically oblique asymptotes are like slant asymptotes. And like you get them by like dividing your numerator by your like denominator.
So rational function can be written as ratio of two polynomials,
Yeah,
numerator over denominator, let us say, right? And of course, the denominator is never equal to 0. That is
yeah,
also to me. So we get oblique asymptote if degree of numerator is equal to degree of denominator plus 1. 1 more than the degree of denominator. Then you get oblique asymptote. You get the idea?
yeah, yeah.
Right. So that is the condition. And how do we find the oblique asymptote? Find by dividing.
Yeah,
So you get the quotient, right?
yeah,
Which is the equation for oblique asymptote. Is that clear to you?
yeah.
Let's take up an example and try to see how do we figure this out. Okay, tell me, what is the example?
Yeah. I don't have any examples. Like,
Okay.
I just wanted to like, I think maybe we could just do what you had, like anything you have for me.
Oh, we can just
Like,
write any equation. Don't worry. We will just write any equation. Okay.
yeah, yeah,
Right?
yeah.
Doesn't matter. So y is equal to, let us say, 3x squared. That question may be very difficult to solve, but we'll just write one equation, right? So let's say 4x, let's make it to the power of 4. 4x cubed plus x squared minus x plus 2. Let us say, this is my equation, right?
Okay.
And I want to divide this equation by, let me write rational function. Let me clear this.
Okay.
So I'm writing a rational function as a ratio of 2, and I'm writing this here, x cubed plus 2x squared minus, let's say, x plus 1, right? And I'm dividing this by a quadratic function. Let's say we have x squared plus x plus 3. Okay. So that's the quadratic function. As you note here, this degree is what?
3.
And what is the degree of denominator? So one more, right? So therefore, we have oblique asymptote. Is that clear? Now, how do we find oblique asymptote? Let's divide. So we are going to divide x, the numerator, which is, oops, what happened?
Yeah.
I'll redo. So the numerator is x cubed plus 2x squared minus x plus 1. And the denominator is x squared plus x plus 3, right? So how many times will that go? X cubed
That will go
x
in
squared.
X, like 1. Yeah.
Yeah.
1.
Plus x squared minus 3x plus 3x. And when you take away, what do you get? You get x squared minus 4x, correct? Bring down.
Yeah.
Now it go one time. And
Yeah.
we have x squared plus x plus 3. And the remainder will be minus 5x plus minus 2, correct?
Yeah.
So that is the remainder. So we do have a remainder and we have a quotient which is x plus 1. Now it
Yeah.
really means that if I have to sketch this graph, then
Yeah.
strictly speaking, we could write this rational function as what? As the quotient, which is x plus 1, right? Plus the remainder, which in this case both negative. So we could write negative here also, 5x minus 2 divided by x squared plus x plus 3, correct?
Yeah.
Now see, we are trying to find what is an oblique asymptote. So
Yeah.
oblique asymptote is defined when x is approaching, let's say, positive infinity or it is approaching negative infinity, correct?
Yeah.
If I am approaching positive infinity, then r of rational function approaches
Yeah.
x plus 1. Do you see that?
X is 1. Yeah.
You see that? Even when you
Yeah.
approach
Yeah.
negative infinity, r of x approaches x plus 1. Do you see that?
Yeah.
So this x plus 1 is the oblique asymptote. So basically, I could actually sketch this x plus 1, which is a diagonal line with x and y intercepts of 1 and minus 1, right?
Yeah.
So this is my line, x plus 1, correct?
Yeah.
So what I'm trying to say here is that the rational function approaches this particular line.
Yeah.
So that becomes the oblique asymptote. Is that clear to
Yeah.
you?
Yeah. That's fair.
One more critical thing which we need to understand here is behavior near the asymptote.
Yeah.
So let's focus on that, which is, let's write down here.
Okay.
Behavior near asymptote.
Yeah.
Correct. So if I am going to positive infinity, you can see from here, I have x plus 1 plus a negative quantity. Do you see that?
Yeah, I see it. Yeah.
Minus 5x and minus 2 will make it negative. So that means negative plus something which is negative. Is it okay?
Yeah, that's
So it means I am going to approach this side from below.
below.
You get the idea?
Yeah.
And on the other hand, if I am approaching negative infinity, in that case, if I make x as negatively large number, then what happens? The numerator becomes negative, right?
Yeah.
Denominator part, x squared is positive, so it will remain positive. So
Yeah.
it will be going from above because we are adding something. So this is my behavior. You understand? So it will
Yeah.
approach the asymptote from above when x
Yeah.
is approaching negative infinity.
Okay.
But it will approach from below when it is approaching positive infinity. Get the idea?
Yeah.
So that is how we could actually relate these functions.
Okay.
Okay, and that is how we could draw the asymptote for the given function, right?
Yeah.
So that's one example. I can take more examples from my videos. That'll be good. So I'll now
Okay. Yeah,
share with
that's
you
fine.
some videos so that we'll take up.
Sure.
Yeah, that'll be better. You can actually go through this my YouTube channel and practice from some questions.
Okay. Yeah, I'll do that.
Okay, so I would like you to, I'm pausing the video here,
Okay.
correct? We have the first question, which is x squared minus x minus 5 divided by x plus 1, correct? We also
Yeah.
shown you the graph. It is quite similar to what we did, right? You see how in this
Yeah.
graph on the right hand side, you're approaching from bottom, right? And on the
Yeah.
left side, you're approaching from above. And that's what we meant, right? So
Yeah.
how do we find equation of this oblique asymptote? We'll do long division, correct?
Okay.
So try it out and can you get the equation of the oblique asymptote? Then we'll compare the answer.
Okay. Yeah. Let's see the denominator.
Oh, I see. Okay. Oh, the screen is not visible to you?
No, I can see. I can see. I just see. I think you just went to a different tab.
Oh,
Okay.
I see.
That's good.
Square
Yeah,
minus
I
x
have it.
minus 5.
Okay. Yeah. Yeah. So it's like x minus 2 is what you get, and then like
Oh, okay.
minus 3 over x plus 1.
Okay, great. So let me just move forward and we'll just compare the result. That's what we'll do.
Okay.
So x minus 2. So you do this long division and you
Yeah.
see numerator, you get x minus 2. And the denominator is minus 3, correct?
Yeah.
Denominator minus 3 means if x is very large positive, then you are approaching x minus 2, but you have to deduct something very small, which is indicated by minus 3 over x plus 1. And therefore, you are approaching from below. You see that idea? And that helps you to accurately sketch the graph. Dotted line shows x minus 2, the line,
Okay.
oblique asymptote. And this is your oblique asymptote, right? And on the right hand side, we are approaching from below. Do you see that? Because of this negative. And on the left hand side, we are approaching from top. Because minus will make it positive, correct? So it will be on the upper. Denominator will become positive when you put negative. Similarly, you go to the next question, which is x squared plus x plus 5 divided by x minus 2. And you get a graph which is similar to shown
Yeah.
in this example, correct? Now let's take up more examples based on this particular concept of oblique asymptote. Now, we have a different question here, which is working in a reverse direction. So can you see this screen?
No, I can't see it. I think you must have stopped sharing.
Oh, is it? Okay. Let me just share again. You can see it now?
Yeah, I can see it now.
Perfect. Can you please read the question and answer?
Yeah. Determine the simplest equation of a rational function y is equal to f of x with the following set of properties. A y-intercept of -3 vertical asymptote along the line x is equal to 4, and oblique asymptote of x plus 2.
How will you do this? Tell me.
Okay, so we have our like denominator,
Yes.
so which is just x minus 4.
Because the vertical asymptote is at this, so we have denominator, which is, I'll change the ink, which is, okay.
Yeah,
X
and then
minus 4.
yeah, so we're given that the oblique asymptote is x plus 2. So that means that we can find the numerator by just doing x minus 4 times x plus 2.
Or we could write it separately, x plus 2 like this, right?
Yeah, yeah.
To do that. And then we have a y-intercept at this, right? So this is this plus, correct? So that's the whole number. And y-intercept is -3. So how do you incorporate y-intercept? That means if I put x equals to 0, then I get -3 as my answer. You get the idea?
Yeah.
So let's say this is a. Put a value a, correct? And you can calculate the value of a. Y-intercept is -3 when x is 0. So find what is f of 0, right? Which is
Yeah.
-3. So -3 equals 2. Here we get 2 plus a over x minus 4, right? And then we can rearrange and get the value of a. So when you rearrange, -2 so it becomes -3 minus 2 equals to a over -4, correct? So -5 is equals to a over -4, or a is equals to 20, correct? So in our equation, I could change this to, and now I can write f of x as equals to x plus 2 plus 20 over x minus 4. Do you see that? So that will be the equation which will be representing the rational function, right? Now, as Aryan, you were saying, you may need to write it in the form
Yeah.
multiply x plus 2 by x minus 4, right? And plus 20, right? So it'll be x minus 4 times x plus 2 plus 20 divided by x minus 4 as your equation. Is it okay? Simplify, expand and simplify to get the result. Perfect?
Yeah. Okay.
That is how you're going to solve this particular question. Clear? Numerator is 1 degree more than denominator.
Yeah.
And we can always find the oblique asymptote by dividing the numerator by the denominator. Correct? So now, when you are given a rational function and we need to sketch the graph of a rational function, then this is a very good algorithm which you could follow. So the algorithm to follow is find the intercepts. That means x and y intercepts. Find the oblique asymptote in this case, because the numerator is 1 degree higher. Any vertical asymptotes, x equals to 3, yes. Maximum and minimum points. Maximum and minimum points we'll get by analyzing the first derivative, right? Make a table of intervals for finding increasing and decreasing levels, point of inflection, intervals of concavity, and once you have all this information, you can sketch the graph, correct? So it basically summarizes all what you have learned so far, including analyzing the first derivatives, and first derivatives are analyzed to find maximum and minimum, and analyzing the second derivatives for finding point of inflection, correct? So I'd like you to go through it later. Let me just share with you some important parts. That is, let's go inside. So x and y intercepts are very clear. To find x intercepts, you have to put y equals to 0. To find y intercept, put x equals to 0. You get those points. Vertical asymptote directly from the denominator, you get. Now for oblique asymptote, you need to divide the numerator by the denominator, as we have started here, right?
Okay.
X squared divided by x minus 3. Now, when you divide x squared by x minus 3, it is important to put placeholders. Do you see I put 0x and 0, right? These two terms. I'm dividing x squared by x minus 3. So when I divide, I really need something to take away the part. So I multiply by x, getting x squared minus 3x, and then we take away from 0x, 3x, and get 3x, and bring down the 0. Divide it further, taking 3 in the quotient. So x plus 3 becomes the oblique asymptote, correct?
Yeah.
Positive remainder means the graph will approach the oblique asymptote from above when you are going towards positive infinity, correct? And will approach from below when you go towards the negative infinity. So that becomes the behavior near the oblique asymptote, whose equation is x plus 3, correct? So we got the intercepts and all these critical points, and we can now move forward to find the other critical points, which is for concavity. So for that, we'll analyze the first and the second derivative.
Okay.
So here we have the first derivative of our equation, x squared over x minus 3. Once you find the first derivative, you find the second derivative. Second derivative will be used to find the point of inflection. Simplify the equation and find all the critical numbers, and then analyze. You see the type of calculation?
Yeah.
I would like you to do this on your own later. I'll share this video, the link of this video on the channel, right? On our class, Zoom class. So I'll stop sharing now, but I would like you to complete this on your own. That'll be a good practice question for you.
Okay.
So here is the link. You can copy the link and complete this question. That'll be a good exercise.
Okay.
So you copy the link?
Yeah, I got it. I got it.
Very good. So now we can actually end the class. Can you summarize today's learnings?
Okay, yeah. So today we first dealt with some problems with inflection points and like how to find inflection points using calculus and derivatives. And we also went over oblique asymptotes and how to find them by just dividing your your numerator and your denominator to see what you get. And you can also tell if a function has oblique asymptote if the numerator's degree is one higher than the denominators.
Correct.
Yeah.
So that's great, and it's a big lesson because we combined calculus with our functions, and I hope it helped, right? So
yeah.
that was very good.